Sandra, thanks a lot for the invite. And this is very true. My expertise is in video understanding and has been since the start of my PhD. And in the past 10 years, our focus has been on recording footage from wearable cameras, known as first-person vision or egocentric vision. And the notion is that we're trying to record from the same viewpoint as the person performing the task. And this is often misunderstood as, you know, a camera that is held and you're walking around and you're observing others. This is not egocentric. Egocentric is what you are doing as you hold the camera. So this is very much replacing your eyes and your ears and recording what you see and what you hear as you move around. And I hope by the end of the talk, I will get a few of you to believe that really doing sight and sound in the egocentric perspective is so interesting, and there are lots of tasks underexplored. And I had explored them by collecting footage. So I'll start by some basic experiments. Make sure that your audio is loud enough, because what you'll see is some sort of sounds of daily life rather than people talking. So make sure your audio is loud enough. And we will start by hearing the sound first and then seeing the footage. Your task is to guess or try to imagine what the footage would be associated with these sounds. Right, let's move now to the visual along with the audio and see how far your imagination was. I'm sorry to be taking a lot of your time, but my intention is for you to hear the types of sounds that you capture when the camera is traveling close to the action, and how different this is from maybe some of the data sets you have been playing with. Again, this is a shorter task. And there is a lot you can conclude from here. Like, I hope all of us can conclude that there is some sort of liquid being poured, but this is where audio might not be enough. So my bet is very difficult to conclude that the liquid being poured is indeed milk if you didn't have the visual accompanying it. And maybe for many years, I was one of these people that thought vision is enough. And the task that I had told you now is maybe saying vision is enough. I can see the milk being poured. So let's flip the task, and we're gonna look at the video without the audio. And surely we all know what's happening here. But if I ask you to identify the moment at which the person is actually turning the blender on and off, my guess is gonna be very, very hard. Here, in this case, and that's basically why I got into audiovisual understanding, we were labeling this data set, similar to many data sets I labeled before. When one of my students came and said, if you really want accurate start and end times, you have to let people hear the audio. And I was like, really? We did a few experiments and I realized there are many, many tasks like turning something on and off, where the audio is the only way for you to accurately figure out. So this was 2017 for me. I, before that, said I am a computer vision person. I don't know multimodality, until I realized how ridiculous that assumption was. Now let's get another example. If you look at this video, you think the person is actually being lazy, not exhibiting any force. Like the video looks like the person is just doing something until you hear the audio. This element of understanding the force this person exhibits only gets clear when you hear the audiovisual aspect. The type of audio you get from these egocentric cameras is so clear, so sharp, and so complex. And I would like to highlight that the types of things that I got exposed to via the dataset was that there are many, many types of audiovisual combinations. There are objects that emit sounds, right? An alarm or a fan. You just hear it and you know it's an alarm. Or maybe it has a variable type of sound like the radio, but you hear it. There is no need for an actual interaction. It emits sound of itself. You might turn it on, but then it's sound emitting on its own. But there is also sound emitting actions. If I ask you to imagine the sound of frying or washing, you know what that is, regardless of the object of what you're actually washing. There are actions where this is significantly harder. Like if I tell you, what's the sound of dropping something? What are we dropping, right? So that's very different between washing and dropping in the audio understanding. There are sound emitting interactions, which is a momentary task when you're closing a drawer or closing a container. And that's very different. It's a combined sound of closing, like chopping onion via chopping versus chopping wood. And there are material-based sounds. So it's the material that's giving you the sound, and it can be combined with many different interactions. I'll give you an example. So what you're hearing here is more of the material rather than the type of action you're doing. And in fact, my experience having looked at some of the audiovisual works, basically to borrow ideas, is that the emphasis is here, is on these sound emitting objects. And without mentioning names, I spoke to lots of people and they insisted that this is the only type of sounds of objects. And I'm like, no, I want the sound of the drawer when you close it. I'm like, no, the drawer doesn't emit sounds. And accordingly, it's off topic for us. So that was a bit irritating. Of course, there are leading works in all of these. And Andrew's here and all the work on kind of emphasizing that you have a fixed action and you emphasize the material by hitting the material or by scratching the material. There are lots of interesting works. But I'm here to tell you that we need all of these combinations to achieve audiovisual understanding. And we're purely scratching the surface in either not identifying the various types, which is probably most of my work, saying let's try to do everything in one go, or trying to only do one of them, but not specialize to methods that do one or the other. And I'll tell you a little bit about my journey in trying to do audiovisual understanding, which is short, but hopefully will incite others to say that egocentric is really a good place to do audiovisual that might be a little bit more than just showing music of pianos. And anytime I pick a paper and it says audiovisual and the outcome is always that I can recognize the piano or the guitar, it drives me mad because of the search I am after for these types of richer sounds. Okay, so what to do first? Where do we even start in this complex problem? And our start was with data, with actually collecting natural interactions with objects. And we did not set to collect an audiovisual data set. We just set to collect a visual data set. GoPro was our best bet because we gave people cameras to take to their homes. GoPro automatically had audio and had IMU measurements. So we said, well, let's collect them. Maybe someone will use them at some point in time. So Epic Kitchens was this data set that we gave people cameras, we asked them to record everything they had done in their kitchen for 3 days. So there were no instructions. But we asked the person to be in the kitchen on their own out of privacy concerns. And that means almost all the sounds that you hear are sounds of actions rather than people talking. There is some speech that comes sometimes from radio in the background, but it's not action relevant. This is a collaboration that we led along with great collaborators from the Universities of Toronto and Catania. And we started, as we said, by giving people cameras. And one of the reasons people haven't done this before is because people don't know how to then ground truth, a collection of unscripted footage. So typical approaches before, they would give people a task, and that allows them to ground truth. We gave people cameras with no task. We said the domain is kitchens, but it included preparing your coffee in the morning to washing the dishes in the evening. So we didn't know what these people were doing. And that's why we came up with this idea of, we borrowed from people who are doing movies, and then we asked people to come back, give us the footage. They would sit in front of the footage and give us a live narration of what the person had done. And that enabled us then to go and do quite scalable, dense action segmentation. And I guess Epic is one of the most efficient in terms of costing because of the approach we've done it. And that's why we call this scaling egocentric vision. Via these live narrations, we were able to just align these start and end times of actions. And we released in 2018 the first version, Epic Kitchens, which we now call Epic Kitchens 55. And then we said, it's never great when you do it first time, so let's reiterate the exercise. It was a bit of a shock when I told the team, we need to do another round of data collection and improve the narrations. And so we went and gave people cameras again. Some of them are the same participants 2 years later, recorded footage in their kitchen, and some of them changed houses. So you got this rich idea of the same person 2 years later. We refined our narrator into something we call the pause and talk narrator. We improved our annotations. And last year we released Epic Kitchens 100, which is available for people to play with, all with audio-visual content. The data is extremely long-tailed. So the y-axis here is log-scaled. This is not a balanced data set. You can never collect a balanced data set with natural recordings. And the classes came out of the people's narration. So we didn't specify them in advance. This is the sentences people gave us that we then made classes out of them. And similarly for objects. We have 97 verb actions, 300 noun classes, and some combinations. So you can't break a tap, for example. So not all combinations are valid. I believe we have around 4,000 combinations of actions, very, very long-tailed. So you get this type of footage now. You have the same kitchen 2 years later and the same sound. And as we said, we have the same people. The basic task that people have been competing on for Epic Kitchens is the action recognition task. The richness of the dataset is a lot more than this, but it's a good starting point. So we give people the start and end time, and we offer them the video and the audio to recognize the action from. And one of the major interesting aspects that this is more on the silent sounds, opening the oven. But as I'll show you, some of these sounds that we can't even distinguish, these networks are able to pick up, like opening a drawer is equally good as closing a drawer. There is still some sort of a sound that you can pick up, maybe because we have several examples from the same environment. And over the years, people have been submitting, and to my shock, most of these methods don't use audio. Audio is there, available. They still choose not to use audio in making the action recognition. If you want to know more about Epic Kitchens, visit the webpage, download the dataset, and we hope that we made it really easy for you to start. The dataset is big, but there are approaches for you to download maybe only the images or only the audio, etc. Then the next step for us to go to the next step, since I had never done audio before, was to collaborate with one of the best teams next door. Vangelis had just joined, and he said, I don't want to do only video. And I said, I have the perfect task for you. You're going to be my audiovisual person in the lab. And he took the mission on board, along with collaborations with Arsha and Andrew at Oxford. And I'll tell you about the 2 works we have published until now. The first work was based on some reading we've done on audiovisual human understanding. So there is an interesting task that psychologists do. So they show you a video of something being dropped, so you hear the breakage, and they actually shift the audio and the video that they're not synchronized. And they ask the people to say whether they're synchronized or not. And up to a certain window, people are completely convinced that they're synchronized. Now that window is small, but not insignificant. And more interestingly, that window is actually bigger in kids or children, babies, than it is in adults. So it's a window we learn or refine as we grow older. So our hypothesis was that if this is the case in humans, this probably might be the case in our learning approach. We might want our network to actually learn to learn an action from a window and be able to take some asynchronous visual and audio approaches and learn from that asynchronous rather than synchronous context. In fact, another way to look at it was that the most discriminative audio and visual might not occur at the same time. Imagine breaking an egg. So the sound of cracking is going to occur a lot longer before when you see the egg, the actual outcome. So the discriminative location, the discriminative audio, motion, and visual appearance changes might not be exactly at the same moment. So we started with this temporal binding window, and we had multiple of these within the action. And then we have an approach similar to TSN, if you're familiar with that. So you would sample a window. From that window, we would sample visual, motion, and audio asynchronously, but we would preserve the order. So we would sample from the first third, the second third, with a bit of overlap. And this taught us a lot about the ability to do audio, the ability to learn from spectrograms and what they mean, and all that background that we needed to approach this problem. And in fact, the building block then was a BN inception, which took a spectrogram, an image, and then optical flow. And the output was 2-headed, so you'd predict the verb and the noun. And in all our approaches, you'll see that we really treat these differently for 2 reasons. One, that allows us to have more combinations, because we have very few, maybe, I don't know, cutting cucumber, but we have lots of cuts and lots of cucumber actions. So that really is helpful for our data set. And we started looking at per action, per class, what is the most discriminative modality? So this is the strongest modality for some of our actions. So in the middle, you'll see actions that are recognized very well by all 3 modalities, like washing. Whether you have RGB or flow or audio, you can be equally good. Let's look at the audio only ones, because these are interesting. Eating is there. And remember that this is an egocentric data set. So the only thing that you can recognize person chewing is the audio, because the camera is actually looking outside, right? It's not, you can't look at the person. So there are certain things like wearing something or eating, where in the egocentric concept, it's only audio that can allow you to recognize the action. Then there is the turn on and turn off, and I show you a few of these examples. Pressing, squeezing. Remember, squeezing could be associated with a certain tool, right? So, etc. And of course, you have things that are better recognized by RGB or flow, but it was very interesting to think about actions recognized best by audio. And similarly, objects recognized best by audio. And things like foil or napkin material gets recognized very quickly. Then extractor fan. There are something like, I don't know, it's blueberry. I can't see all my things, where it's actually the grapes or blueberry, where the packaging tend to have a very distinctive sound. So every time you kind of see them, it's the same sound of packaging. And interestingly, flow isn't really good in recognizing nouns unless they're tools, right? So a knife or a spoon, that's when it's the motion that gives you the action. So this was very informative for us and very interesting. And in fact, TBN, which is the method we proposed, we showed that audio is really helpful. And it's still, even when we went to Epic Kitchens 100, so this was the first version of Epic Kitchens, this still remained fairly competitive to some of the more recent benchmarks, particularly on tail classes. Remember that none of these other benchmarks uses audio, but it's also always interesting that whenever we have audio, it does help those tail classes that have discriminative audio. Okay, a few examples. So, okay, so you'll see things recognized purely by audio, and you'll see the three different modalities. I think there are more examples on the webpage. Right, what's next? Where do we go from our initial TBN? The next bit was actually to look at the two types of sounds that are very, very clear in our data set and relate them to sounds that humans understand. So in our data set, there are harmonic sounds. So these are sounds that are more throughout the thing, you can hear them and they have a particular frequency. And there are percussive sounds. And interesting, this observation exists even outside Epic Kitchens in collaboration with the people at Oxford. That is the same thing for BGG sound. And that's also the same case for maybe things that involve humans and animals. So what do we do? And in this case, we thought the best way to improve our performance is to focus only on audio. Let's see what we can do purely with audio. There is strong evidence in neuroscience that there is also a ventral dorsal stream in the auditory system, not only in the visual system. And this notion of understanding when versus what has been explored really well in the visual aspect with things like the slow-fast network. So this is purely vision, where you can take maybe a video in and you take a high frame rate and a low frame rate and you then merge them. And the idea is that you would attend more to the fine-grained actions as well as the overall context. And we basically took this into audio and saw what we could do with that. So in our case, you would take the same audio, you would sample it differently in terms of time. You would have a slow auditory pathway and a fast auditory pathway. Importantly, the slow one is usually having low temporal precision, but lots of channels. We're copying the concepts here. And the fast has fewer channels, but a higher temporal resolution. And you would be merging the concept from the fast to the slow with lateral connections. The inspiration we have is the same as the slow fast inspiration of the auditory, the dorsal ventral concept in humans. And we're using here separable convolutions because it's not like an image, right? So the time and the frequency aren't really a homogeneous axes. So we're having separable convolutions in space, in the two axes, so in frequency and in time. And the results were really good. This is achieving best performance currently on BGG sound. We also use the pre-trained version on BGG sound to train on Epic Kitchens. And we're here comparing audio only on our data set. And we're seeing some improvements. The improvements were not very easy. I think we're still very far from how we want to utilize audio, but this is one step in that direction. And we can show that again in the audio, in the slow stream, performance is better for the types of tasks that we were after, like animals, hissing, bird calling, buzzing, and scenes. And then also on the fast stream, we see more of the percussive sounds. And some examples, this is audio only, and you'll see the performance of slow, fast, and the combined model. This is from Epic on the left. And from BGG on the right. And I like the last example because I think, it really shows the abilities of slow and fast and the ambiguities you would have if you look at different temporal resolutions.
It'll go. Closing it, still get that repeated clicking, pounding.
So this person is complaining about the problem in sliding a door. If you want to know about this auditory slow fast, the code and the models on both VGG Sound and Epic Kitchens are out there for you to play with. And as you can imagine, our next step is to try to combine this now back with the visual setup, which we're working on at the moment. If you're asking yourself, is there enough data for me to be involved in egocentric audiovisual? Hang on, something big is coming very, very soon. We're part of a big consortium to collect more than 6,000 hours of audiovisual egocentric data. It's very much following the concepts of Epic Kitchen. Give people cameras and ask them to record what they do. It's outside the kitchen. It has other kitchen things, but I'm not showing you only the kitchen. And it's both indoors and outdoors. Soon, this will be a very, very rich resource of audiovisual information. I get the pleasure of presenting this work, but this is very, very hard work of a big and very dedicated team. Everybody in the lab works with something to do with Epic Kitchens and making sure it's ready, available for others to use. So I'm grateful for their hard work and dedication, and I have the pleasure of working with them. If you have any questions, I'll be happy to take them.
Thanks so much for the excellent talk. If anyone has a question, they can either post it to the chat, and then I'll read it out so the people on the live stream can hear it, or you can just unmute and ask directly. Yes, so I have a question. You said that there were some cases where the audio was unexpectedly good at classifying certain events. Like I think you said shutting a door and opening a drawer. I was wondering if you could tell us a little bit more about that.
So there is a combination of things. The most obvious, as I said, was turning on and off things, because imagine your coffee machine, right? And if you press the button, it will start. If you press a button, it will stop. The only thing that makes a distinction is the audio. So there are certain cases where the visual is completely unhelpful, like zero information. Then there are transparent stuff like water. So turning the tap on and off. Again, visual was a lot better than the auditory was a lot better than visual. But there were other subtle stuff, like opening something, that I would just say, I would first question whether the method is able to pick the actual moment you're opening something. And then when we visualize, it is actually capable of doing that. As I said, maybe because we have this rich information from the same environment, and in many cases, we have the same environment in training and testing, but it was also performing well in unseen kitchens, so new kitchens. However, kitchens have very, very similar material. So all our cupboards tend to be wood. All the water has the same sounds. So within that domain, there is a lot that you can transfer. The sound of frying something is the same. And in fact, we had work on domain adaptation, where audio, our domain adaptation challenge has audio features. And today, the 3 top winners of the challenge all used audio and thought audio was very helpful when you have transformed into a new environment within the kitchen domain, because the sounds of knives and forks and the material is very, very much the same. So that was our experience, at least.
Great. Are there other questions?
If I have transformed one person to say, I would like to work in egocentric audiovisual, that would be an amazing achievement. Drop me a line and we will be very happy to help you get started.
Yeah,
maybe I can ask a follow-up question. I think audio visual learning is probably, it's like audio is very helpful in egocentric videos for action recognition, but usually for like third person video, for third person videos, like YouTube videos, audio is super noisy, right? It's hard to use that for action recognition. So do you think usually only for those egocentric videos where audio is playing a crucial role, but is it possible to actually use audio for those common YouTube videos? Do you think is there any potential there?
So what are the common YouTube videos? That's always my questions. For example, most of them are recorded from TV, where you're talking about, there are lots of people talking, right? You can remove the speech, but then you're not left with much, right? Because the emphasis is that. But more and more people are recording their daily vlogs, if you can call them. And these will have similar ideas, but probably most of our data sets isn't that. They're mostly curated footage with lots of people talking. Yeah, so if we can make the distinction between speech and non-speech, there isn't much non-speech audiovisual out there as yet.
There's also a question in the chat. The question is, among the top performance algorithms, what new mechanisms are impressive during the challenge?
Ooh, during the whole challenge. So we have 5 different challenges on action recognition, anticipation, detection, unsupervised domain adaptation, and multi-instance retrieval. I am biased because I am very interested in domain adaptation. And I think what is good about our challenge, and the technical report will be available beginning of next year, is that the methods aren't doing well because they are ensembles. They're doing well because they tend to be publishable works. They still need to produce some novelty. So I would say on almost every challenge, there's something that is either recently published or under review or something that is related to introducing. The UDA to me is the most interesting bit, which is trying to recognize different kitchens or trying to recognize after 2 years gap. There hadn't been a domain adaptation video data set before. So we really offered that opportunity, making the most of maybe lots of ideas that people want to put into the domain adaptation. Lots of interesting, amazing ideas, I would say, in the challenges presented this morning and will be available soon on YouTube for you to hear. Perhaps the most impressive is the need to do higher resolution when it comes to footage compared to third person. So remember that the camera is around where your eye is. And in fact, the pixels representing, I don't know, you cutting a tomato are so small compared to other things. So many of the other action recognition data sets, starting from kinetics and ending with something, you can get away with small spatial resolution. And that's not the case with Epic. So all the interesting ones to me today, this morning, we're trying to explore the higher resolution and doing a lot better. The question is how to localize where you want to be in this high dimensional footage.
If there are no other questions, I have one other question. I don't know what you can say about Ego 4D, but are there challenges planned?
Sure.
Audio or is it?
Sure. Ego 4D is a very interesting collaboration of 12 universities. We were put together first to collect a big data set. So the notion is we all collected data for all the various challenges, and we have multiple streams. There are people like me very interested in hand-object interactions. So if you're after that, there will be a lot of that in the data. But there is also multiple person. There is social aspect. There are people talking, playing games, doing stuff. So there are multiple camera wearers doing tasks. And there is a very strong stream related to, I wouldn't call it VQA, but would be related to the interaction between asking a question and being able to answer it within the dataset. So these are the 3 big streams that we have. But as with Epic Kitchens, the data will prove more useful than even the challenges we will initially define. The latest paper that came out on Epic Kitchen was doing SLAM and building 3D structures out of the data because we have lots of footage. So I think the data will prove richer than the challenges, but these are the 3 streams, at least the 12 starting universities are very interested in. So we'll be hand-object interactions, whether it is recognition or anticipation. There will be a very strong social stream on multi-people doing stuff, understanding emotion, gaze, and predicting people talking. And there is a strong stream on being able to do maybe longer sentences and search for something. Where is my key? I think is a good title for this type of strand. Amazing effort, lots of people involved. We started collecting just before the pandemic. The fact that we managed to continue during the pandemic is thanks to the power behind it, which is Kristen Grumman. I think at some point we thought we can't collect during the pandemic, and then we stopped for a while, but we thought, what can we do during the pandemic? We shipped cameras to people by post, and that allowed us to collect from places we haven't even considered in the first place. I think in the UK, for example, we shipped to the Isle of Wight, which is like this island somewhere in the north, and we were able to collect footage from there. So cameras were shipped, people were trained via Zoom, an impressive effort. And the pandemic was not a blessing, but I think it allowed us to do something we haven't thought we could do. The data is anonymized, so people have been blurred in most of our footage, but that doesn't stop us from being able to ask the interesting questions and hear very clear egocentric audio.
Great. Well, there's one more question, but unfortunately we're running out of time.
Before I finish, if you want to know more about Ego 4D, so the next Epic edition, which is the 9th edition alongside ICCV, it's labeled Epic 9th edition, introducing Ego 4D. So ICCV, October will be the time where the data will be hopefully with you, and we'll be able to tell you all the details about how to use it. We're at the process of finalizing the annotations and the benchmarks.
Great. I'm definitely looking forward to that.
Thanks for the invite.